Welcome to the DIY Honda Garage channel. The DTC P1458, which refers to the FTP sensor circuit range/performance problem, specifically affects the fuel tank pressure, or FTP, sensor, a critical component of the vehicle's evaporative emissions system. The FTP sensor is responsible for monitoring the pressure inside the fuel tank, ensuring proper fueling and emission control. It is primarily located near the evap canister, which is typically found on the underside of the vehicle, close to the fuel tank. This sensor provides vital data to the powertrain control module, or PCM, enabling it to adjust fuel mixture and emission levels accordingly. A malfunction or poor performance of the FTP sensor can lead to various issues, including increased emissions and decreased fuel efficiency. Understanding and diagnosing this DTC is essential for maintaining your Honda Pilot's performance and compliance with emissions regulations. The fuel tank pressure FTP sensor is integral to monitoring the fuel tank's pressure levels, which is essential for the evaporative emissions control system. Located near the evap canister, this sensor communicates vital pressure information to the powertrain control module, PCM. An error occurring in the FTP sensor can lead to the triggering of DTC P1458, indicating that the sensor circuit has a range or performance problem. Proper operation of the FTP sensor is critical in ensuring that fuel evaporates correctly and that the emissions system functions as designed. The sensor values can fluctuate during operation, and discrepancies can result in detection of DTC P1458, potentially affecting the vehicle's overall emissions performance. Thus, identifying any issues with the FTP sensor is crucial for compliance with environmental standards and to assure the vehicle's efficient operation. Several possible causes may lead to the DTC P1458 being triggered. A faulty FTP sensor is the primary concern, which may not function as expected, leading to inaccurate pressure readings. Additionally, a blockage in the vent hose can affect the airflow necessary for the proper operation of the FTP sensor, thus causing performance problems. Loose or corroded electrical connections to the FTP sensor or the powertrain control module, PCM, can also contribute to erroneous sensor readings. It's important to systematically check these potential issues, as they can each prevent the FTP sensor from accurately reporting the fuel tank's pressure, ultimately triggering the DTC. Addressing these underlying issues is critical to resolving the fault indicated by DTC P1458 and ensuring optimal vehicle performance. When DTC P1458 is present, several symptoms may manifest, indicating that the FTP sensor or its associated systems are not functioning correctly. One of the most noticeable signs is the illumination of the malfunction indicator light, MIL, on the dashboard. Drivers may also experience a decline in fuel economy, which highlights inefficient fuel utilization and potential performance issues. Increased vehicle emissions can be another critical symptom, as an improperly functioning FTP sensor can cause the vehicle to fail emissions tests, leading to further complications. In some cases, owners may notice changes in vehicle behavior, such as strange noises or reduced power during acceleration. Recognizing these symptoms early on can facilitate timely diagnosis and repairs, ensuring compliance with environmental standards and preserving fuel efficiency. The first step in troubleshooting DTC P1458 involves turning the vehicle to the on mode without starting the engine. This allows the technician to access the onboard diagnostic system through the Honda Diagnostic System, HDS. During this process, it's crucial to check the recorded snapshot parameters, specifically the max and min values of the FTP sensor and the fuel level. These values will help establish a baseline and facilitate the next steps in the diagnostic process. The fuel level noted during this check should be compared to the current fuel level being displayed by the HDS. If the current fuel level is less than the level recorded in the snapshot, follow the specified action to make sure the fuel level is appropriately adjusted for further checks. In the second troubleshooting step for DTC P1458, the technician will select the EVAP test option from the inspection menu of the HDS. This is critical because it allows the technician to assess the performance of the FTP sensor under controlled conditions. The next task is to select the EVAP CVS off in the single solenoid option, while taking a snapshot for 3 minutes, again, without starting the engine. Afterward, the technician must analyze the recorded snapshot parameters, specifically the fine values for the max and min of the FTP sensor. These pressure values are essential for determining if they fall within the acceptable range of plus or minus 0.67 kilopascal, 0.2 inch A, 5 millimeters Hg. Understanding these readings will direct the technician on whether to continue with the next step, which focuses on the FTP sensor performance check, or to delve deeper into other potential issues indicated by the findings. Step 3 focuses on performing a detailed performance check on the FTP sensor. During this phase, the technician will examine the recorded values for the FTP sensor, fine, as captured during the previous snapshot. The technician must determine if these values vary by at least 0.067 kilopascals, 0.02 inches, 0.5 millimeters inch-again, or more within a period of 3 seconds. If such variability is observed, it suggests that the sensor is functioning correctly, and the technician can proceed to the next step. Conversely, if the variation is insufficient, it points to an intermittent failure, which may indicate that the system is operating well at the moment. Hence, checking for poor connections or loose terminals at both the FTP sensor and related components is crucial. Additionally, blockages in the EVAP vent hose must be investigated, as they could be impacting sensor functionality and leading to P1458 detection. In the fourth troubleshooting step, the technician will turn the vehicle to the off-lock mode and proceed to remove the FTP sensor for further diagnosis. After the sensor is detached, it's crucial to reconnect the FTP sensor 3P connector securely to ensure accurate readings. The technician will again turn the vehicle to the on mode and need to check the FTP sensor fine parameters using the HDS. The objective during this step is to determine whether there is a variance of 0.067 kilopascals, 0.02 inches, 0.5 millimeters inches, or more within the 3-second time frame. If the readings indicate that such variability is present, it suggests that the FTP sensor is faulty, thus necessitating its replacement. However, if no sufficient variation is detected, this indicates an intermittent failure, warranting further inspection of the connections and possible blockages in the EVAP vent system. The fifth step of troubleshooting DTC P1458 involves inserting an emergency fuel funnel into the fuel filler neck before monitoring the system. The emergency fuel funnel is stored within the maintenance lid of the left side trim panel of the vehicle for this specific purpose. After allowing 1 minute for conditions to stabilize, the technician should consult the HDS to check the respective parameters for the FTP sensor. Fine. Specifically, the current pressure should be evaluated against established thresholds, which are set at more than 0.67 kilopascals and less than negative 0.67 kilopascals. If the current conditions do not align with the threshold requirements, a more in-depth inspection is warranted. This corresponds to removing the funnel and progressing to the subsequent troubleshooting steps, where blockage or further failures might be addressed thoroughly to resolve the DTC P1458. Step 6 requires the technician to turn the vehicle back to the off lock mode and remove the FTP sensor once more for diagnosis. Reconnecting the FTP sensor 3P connector is critical for ensuring subsequent parameters can be accurately checked. Afterward, the vehicle is once again turned to the on mode, so the technician can utilize the HDS to check the FTP sensor fine. Similar to the previous steps, the technician must assess whether the conditions match specific thresholds, which should indicate a value above 0.67 kilopascal and below negative 0.67 kilopascal. If the current conditions do align with these prescribed thresholds, it indicates that the sensor is likely functioning correctly, enabling the technician to progress to the next checks. If the readings do not match the thresholds, this can indicate a blockage within the FTP sensor vent hose, requiring further attention to either clear the obstruction or replace the hose if it is damaged. The seventh step in diagnosing DTC P1458 involves returning the vehicle to the off lock mode and disconnecting the FTP sensor 3P connector to enable visual inspection. This step is vital as it allows the technician to thoroughly check for potential blockages or damage at the FTP sensor ports, including both the evap canister side and the vent side. Inspecting for any physical obstruction is crucial because even a small blockage can lead to the malfunction of the FTP sensor, triggering the DTC. If any blockage or damage is detected during this visual inspection, it should be addressed immediately to restore proper function. In cases where damage is sustained, replacement of the FTP sensor will be necessary to ensure proper operations within the evap system. In the final step, the technician should start by turning the vehicle to the off lock mode again. They will then disconnect the evap canister vent hose from the canister and connect a vacuum pump or gauge rated from 0 to 30 inch per minute to the evap canister to check its integrity. Following this setup, the vehicle should be turned to the on mode and the evap test should be selected from the inspection menu. The technician must apply vacuum to the valve carefully, ensuring not to exceed 5.3 kilopascals, 1.6 inch per minute, 40 millimeters mg, which can cause damage to the FTP sensor. Finally, they must monitor the FTP sensor fine values using the HDS. If the valve holds more than 1.3 kilopascals, 0.4 inch per minute, 10 millimeters mg of vacuum, the evap canister vent shut valve needs replacement. Conversely, if it holds less than that, it indicates the valve is functioning properly, necessitating removal of any blockages in the evap canister vent hose, ensuring thorough diagnostic clarity. Upon completing the necessary repairs and replacements for DTC P1458, it is crucial to undertake a final verification step. This step involves confirming that all related sensors are functioning correctly and that any parts replaced, such as the FTP sensor or the evap canister vent shut valve, are operational. Following this confirmation, a diagnostic scanner should be used to clear any diagnostic trouble codes DTCs that may have been logged during the testing process. Subsequently, a test drive of the vehicle is essential to ensure no reoccurrence of the T1458 code and that the vehicle operates as intended. During the test drive, observe for any check engine light illumination or unusual behavior, as this will provide further insight into the overall repair effectiveness. This stage solidifies the accuracy and reliability of the completed repair, contributing toward achieving optimal vehicle performance. To reduce the likelihood of encountering DTC P1458 in the future, proactive preventive maintenance is essential. Regular inspections of the EVAP system components, including the FTP sensor, vent hoses, and canister, will assist in identifying potential issues before they escalate into serious problems. Furthermore, keeping a close eye on fuel levels can prevent unnecessary fluctuations that may influence sensor readings, diminishing the chance of triggering DTCs like P1458. It is also prudent to maintain sensor cleanliness. Dirt or debris accumulation can affect sensor performance, leading to erroneous readings. Conducting these simple yet effective maintenance practices can extend the lifespan of the components involved and enhance vehicle reliability while ensuring compliance with emission standards. DTC P1458 pertains to the performance problems encountered in the FTP sensor circuit, a crucial component associated with the vehicle's evaporative emissions system. Understanding the role of the FTP sensor in monitoring fuel tank pressure is vital in addressing any related issues effectively. Following the systematic troubleshooting steps outlined not only ensures accurate diagnosis, but also facilitates efficient repairs. Additionally, performing regular preventive maintenance can significantly reduce the chances of encountering similar DTCs in the future, improving both vehicle performance and emissions compliance. Ultimately, being proactive and informed about the vehicle's diagnostic systems builds a more reliable driving experience for Honda Pilot owners over the long term. Please like and subscribe to the channel. See you next time.